All right, welcome back. This time we're going to go over AWS Lake Formation for data lakes. But before we get started, hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning Associate exam. Lake Formation is a fully managed service for building, securing, managing, and governing data lakes on S3. It simplifies and automates complex tasks involving in setup and maintaining secure, performant data lakes. Lake Formation builds on AWS Glue, supporting data ingestion from S3 databases and NoSQL sources, both on-prem and in AWS. Data cataloging with transformation and cleaning, fine-grained access control for S3 stored data, integration with analytics tools like Athena, Redshift Spectrum, and EMR, and ACID transactions, with row and cell level security. Well, we'll talk about that. I was going to say via governed tables, but that's updated. All right. So what are some core capabilities? All right. So Lake Formation ingests data from S3, JDBC sources, Kinesis, DynamoDB, or on-prem systems, right? ETL and transformations can use glue jobs running Spark or Python shell to clean and format data into Parquet or ORC formats. Data cataloging can store metadata for tables, partitions, and schemas. Security features include column, row, and cell level permissions, integrating with KMS, IAM, Resource Access Manager. Audit and governance can track access logs, data sharing policies, and query history. And ACID transactions can appear with support for multi-user read-write consistency. Lake Formation serves as a control plane for your data lake, orchestrating Glue, S3, IAM, and related services to streamline secured data lake creation. All right. So how does this work with machine learning pipelines? All right. Lake Formation prepares and secures large volumes of diverse data before use in training or inference. It enables secure ingestion of training datasets in the SageMaker, provides role-based access for machine learning teams to specific rows or features, transforms data efficiently to columnar formats like Parquet or low latency Athena or EMR queries, right? It also supports streaming ingestion from Kinesis and maintains unified metadata catalogs for feature engineering pipelines. There's also some cell-level security to enable multi-tenant machine learning platforms, isolating data access across teams. All right, how much does this cost, though? All right, let's get the numbers. Okay, so Lake Formation itself is free. You pay for the underlying services like S3 storage and requests for data lake with glue crawlers and ETL jobs and data cataloging, right? Athena also has pay per query data for scanned data. Redshift Spectrum has per query gigabytes for scanned data as well. EMR cluster time and data access also has charges. Then there's also transactions and compaction with storage IO. And data filters can affect your query performance and storage usage. All right. So we're going to go show you a little bit. Let's see. Lake Formation. All right. So Lake Formation, right? So if you have an S3 bucket, you can set it up, name it something like, data lake bucket, right? Have an IAM role with Lake Formation permissions, access it for S3 for Glue and KMS for encryption, right? And then you can have optional access to data sources like RDS if you needed, and you can have a KMS key for encrypting the data lake too. All right. So from here, go to, yeah, we're in the catalog. All right. Let's see. Man, this is going to be multi-step. We're not going to do that. All right. So basically, I'll just tell you, you need an S3, okay? And then you're going to need to create a glue crawler or import the schema. You're going to set the target database and crawl your source from S3 over the files that are in there. In Lake Formation, you have the permissions that we were talking about earlier. Choose database permissions, table permissions, and assign the IAM role with that and define it to go there, all right? But you're going to basically create the S3, create the catalog, create the crawlers, have the databases, and then you should be good. Okay. Let's go a little bit more. Let's go to security. Okay. So Lake Formation offers column, row, and cell level access control through some data filters. It has column level security to include or exclude columns during select permissions, and it has row level security with SQL-like filter expressions. The cell level security combines both filters for granular access, and these permissions enforce at query time for Athena, Redshift, and EMR. All right. You can also create the data filters, right? So let's show you. In here, you go data filters. Okay. Data filters. All right. You can create a new filter. All right. Specify the name, add the database and table, the column level access, selecting all or include, exclude specific columns, and you can have row level filters right here. Okay. And you can have the expression set up here, or you could do this with what do you call it? CLI, right? You can just use the CLI for programmatic filter creation, specifying the table name, the database name, the row filter expressions, the column names, right? But you're going to have to get good at using that AWS CLI for that. All right. So this is one thing I alluded to earlier. Okay. So I was going to talk about governed tables. This is being deprecated. All right. So you're going to be able to migrate these. And here it is. Your lake formation, governed tables will remain there for some time. Okay. So what did governed tables do? Governed tables had ACID properties, which are key for anyone who's a DBA, right? So that's the basic properties: atomicity, consistency, isolation, durability, right? For S3-based storage. So it allowed concurrent updates, transactional read writes, time travel, rollback, and query consistency with Athena, EMR, and Redshift Spectrum, right? So it was good for streaming ingestion from Kinesis, Kafka, machine learning with consistent views and batch, plus real-time hybrid pipelines, right? And so it was good to be created for tables so that tables couldn't change and could maintain consistency. So now they're going to go back to more standard tables, and you'll see here that they have some information about what they're actually going to do. If they already exist, they'll be fine. If they don't, they're going to be, preserved. All right. So that, just note that for anyone using data lakes. All right. Access control. All right. So IAM policies are required for Glue jobs, KMS, and S3. Lake formation permissions control database and table level access. Data filters provide optional fine-grained access control. Cross-account access requires RAM, Resource Access Manager, with recipients listed as the data lake admins. And encryption will require IAM permissions allowing access to relevant KMS keys. And then manifest files will be used in Athena for predefined S3 paths, but they're not quite yet supported for lake formation managed tables. So this might cause query failures. So just be careful what you're doing. All right, for the exam, remember a couple of things. When you're asked about securing data lakes, implementing fine-grained access control, or enabling transactions on S3 similar to a DBA for machine learning feature stores, lake formation is typically the managed service to orchestrate that secure data lake creation and governance across your analytics and your ML workflow. All right, so thank you for joining us. Hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning exam, and we'll see you soon. Thank you.